Einstein predicted gravitational waves 100 years ago, and scientists have been trying to detect them. In 2016, for the very first time, we realized that beneath all the lights in the dark and undetectable to us are a sea of gravitational waves. Hi everyone, my name is Jielai Zhang.
Hi, my name is Nutsinee Kijbunchoo.
Hi, my name's Thrane, and I am a member of OzGrav, the ARC Center of Excellence for Gravitational Wave Discovery. The theme of OzGrav is gravity, so understanding black holes, ripples in the fabric of space-time. All of these are things that are predicted by Einstein's theory of general relativity, which is our best theory of gravity. The goal of OzGrav is to use gravitational waves in order to understand the universe around us, looking to understand the fate of some of the most massive stars, which collapse and can form black holes, or how matter behaves at the most extreme possible densities.
So we have both theory side and experimental side. The theory side focus on analyzing data and understand the signal that the gravitational wave detectors have detected. And for the experimental side, we are developing a technology for future generations of the gravitational wave detectors.
A gravitational wave is a ripple in the fabric of space-time.
What you actually observe when a gravitational wave passes through is a length change. And so let's say my arms are super sensitive at detecting length changes. As the gravitational waves comes through, the distance between my hand will actually fluctuate as the wave passes through. The kind of distance change as a gravitational wave passes through is absolutely minute. It's less than the size of an atom.
Gravitational waves is everywhere. It's passing through you and me, and we just don't even realize it. It's just a distortion in space-time. And now imagine you have these giant black holes in space colliding, and these gravitational waves travel to Earth.
Now, when one of these ripples passes through us here at Earth, it causes us to be slightly stretched, first this way, then this way.
Our existence itself is being distorted. My field of work is quantum optics. I deal with laser, magic crystal, and entangled photons. By manipulating the light, we are able to use technology to improve the sensitivity of the gravitational wave detectors.
I study explosions and collisions in space. I get to use telescopes of all different wavelengths, as well as gravitational wave detectors. These things help us understand how things collide and explode, and really help us understand how the elements in the universe are created.
I work in gravitational wave astronomy, which means I use data from detectors like LIGO, which measure ripples in the fabric of space-time, in order to work out the properties of black holes or neutron stars as they smash into each other many light years away. The best part of being involved in OzGrav is that I am part of an international team of researchers throughout Australia who are tackling some of the biggest problems in astrophysics. I think if we were all working as individuals, we couldn't take on such ambitious projects.
It's globally connected. I was sent to LIGO Hanford, Washington State. I had a chance to actually meet other scientists from other institutions that not just within Australia.
Another really cool part is OzGrav does a lot of outreach. And so as you discover how the universe works, there's people helping you, telling the public about it as well.
If I had the opportunity to meet another physicist from the past, I would have loved to have been able to chat with Stephen Hawking.
I would love to meet Einstein and just tell him, dude, you're right. Black holes are real, gravitational waves are real.
Vera Rubin, she was the one that discovered dark matter. The discovery she made completely changed our understanding of what the universe is made of. And she did that as a graduate student, as a woman in a time when there were not many women scientists.
If I could travel anywhere in the world right now, I would love to go back to the US because I have a boyfriend there.
If I could go anywhere in the world right now, I would want to go to Japan to go snowboarding.
I think I would like to visit India. I've never been to India before. I hope to be able to visit someday. In addition to science, I'm passionate about music. I grew up playing violin, so I like rock music as well. And during quarantine, I had some concerts for the neighbors that they did not invite me to perform.
I like traveling, I like meeting new people, I like setting out without a map, without knowing where I'm going.
I draw a lot of comics and I made lots of videos, so my other passion is actually art. I draw comics about my journey through PhD, my journey through battling with mental health, and I just want to tell them that if they're battling with mental health issues, they are not alone.